Hello, my name is Angelo, a regional sales manager for Prier Products, a wall hydrant manufacturer based out of Kansas City, Missouri. Today, we want to talk about frost-proof wall hydrants. We are going to cover the basis of things that can happen with these valves and give you an education that makes you more knowledgeable when it pertains to these type of products in the field. For our wholesalers, this makes you more valuable to your plumbers. Plumbers, this makes you more valuable to your customers. And in turn, you have a knowledge that many others do not have. We want to be that avenue for you to get a resource to make you more knowledgeable. So today, we are going to cover a couple things on frost-proof wall hydrants. We want to talk about what is a frost-proof. We want to talk about what can go wrong with a frost-proof and how to fix those issues in the field. And in turn, if you can't fix it, we're going to have to eventually maybe consider a replacement. We're going to cover that as well. And then we want to talk about some codes that are pertaining to these types of products. So first thing we want to talk about is what's frost-proof. So you're going to hear this in several different names throughout the country. There's going to be freeze-proof. There's going to be frost-proof. There's going to be wall hydrants. There's going to be spigots. There's going to be hose bibs. Essentially, many of these go by different names, but they mean the same. When you see freeze-proof, you see frost-proof. What this means is where the water is going to be shutting off, and we're going to address that in a little bit, but we want to kind of dive into, the history that comes from these types of outdoor valves. Looking at a little bit of the searches online, they're a little tough to determine where these valves actually started back in the day, but you can trace outdoor valves all the way back to the 1700 BC time frame. The Roman Empire was using these. Obviously, the ones that brought us the aqueducts and all those, they're using outdoor valves to do public baths and to do private baths and offering water supply systems to their fountains. So water being sourced to an outside shutoff can actually be traced all the way back to the 1700s. Now, obviously, not many different things were happening between that time frame, and you don't hear much about a spigot per se until about the 14th century, and that's where Merriam-Webster actually defines a spigot as a shutoff of a faucet or a plug for a sillcock. So you kind of start to hear that terminology a little bit more around that time frame. Now, these valves worked great for many, many years. They provide that water source to many different applications, but you had many regions that were experiencing freezing conditions for long periods of time. Essentially, think of anywhere north of that Mason-Dixon line here in the US, but that's going across the entire world that you are going to see freezing conditions in certain markets. And what was happening with some of these valves is it was causing these to freeze up and sometimes rupture the supply line. So in the 1940s, we had the frost-proof was born. You're going to see a handful of manufacturers that ran out with this particular type of model around the early 40s. Prier being one of them, as well as many other manufacturers at that time, really caught on to it because it's a very value-added product. Now, you're also going to notice, quick little thing that Al Moen, who many of you may know from mowing faucets, he was actually one of the designers of the very first mixing valve. So before this time, they were actually taking two valves to supply all hot, all cold, no intermixing. It was all kind of mixed through two different valves. And Al Moen in the early 40s as well designed a mixing valve that put it all in one head. So, and of course, you'll see some of those products with hot and cold valves in the marketplace today. Now, since the 40s, those valves ran with no changes essentially up until about the 1970s. Now, the 1970s, the government enacted the Safe Drinking Water Act of 1974. Now, this act is actually going to push in some backflow preventions, anti-siphon vacuum breakers, and things we're going to cover a little bit later in this presentation. But since those 1970s changes, not much has changed on the valves besides maybe designs and offerings and aesthetics. The valves have been solid through and through, essentially since the 40s and the 70s. All we did is we added some backflow prevention devices, but the valves still carry true to this day. And one of the reasons they do is the simplicity of them. With a frost-proof wall hydrant, your main difference is where the water is shutting off. So with a hose spigot or a hose bib, where the water is coming all the way up to the head of the valve, your water supply line is coming all the way into that portion. Again, going back to those colder climates where you're having freezing conditions for extended periods of time, these valves were prone to freezing. That water was going to expand and cause issues on the supply line because the water is all the way up to that point. So with the frostproof, all we did is we took that shutoff that you see in that bottom left and we moved it inside the heated part of the building. So you'll see on the right side there is a shutoff that's taking place, and the diagram up above also shows the exact same product where you're extending the shutoff into the heated part of the home. Now, when I say heated part of the home, one thing that we always want to point out is people need to understand, we say heated, that means it needs to be in a decent range. We have some, vacation homes where they're setting the thermostat on 40 or 50. This may not be sufficient enough in some applications. If you're hitting single digit or lower numbers on the exterior part of the building or the home, that temperature is radiating through that brass, through that copper, and it can extend all the way back. It can still freeze that supply line if you are not keeping those inside parts of that building warm enough. We ran into a couple complications where some people were barely hitting 40 degrees on the inside and still having some issues with the water freezing. Thankfully, nothing broken, busted, but they couldn't use their valves until things de-thawed. So very important to remember, when we say a heated part of the home, that means the temperature needs to be probably at least 50 degrees on the inside of the building for it to maintain, depending on how cold it gets outside. Now, things that can actually happen with a frostproof that cause problems. There's really two things that are going to play a factor here. The very first thing we want to address is probably the number one cause of why a frostproof is going to fail. And when we say fail, that means it is no longer working. It's got to be replaced. And one of the major reasons, in fact, I'd say 9 out of 10 times, if not higher, is because a hose is left on the valve. A frostproof only works when it is allowed to vacate the water from the system and leave a hollow pipe. If you have a hollow pipe, no water left inside to freeze and expand. With a hose left on, or a splitter, or a timer left on, that water, even though is shut off, has still trapped water inside. And what you're going to see is in a freezing condition over a long period of time, and that's a very important thing to point out too, if you get a cold snap and you only get a couple hours of below freezing temperatures, you're probably not going to need to worry about it too much. But if you're getting ready to see long periods of freezing temperatures of several days or extreme colds, this is when this is going to play effect. Your water is going to slowly begin to freeze from the outside, and that cold is going to radiate into that pipe. And what happens is that pressure on that water begins to get so high as an ice dam forms, and it's going to push close to 4,000 PSI, and it looks for the weakest part of the valve. And in many cases, that weakest part is the copper. So what you end up seeing is a split pipe towards the back end of the valve. So we want to make sure people understand you have to remove the hoses. In fact, I know many people use what you see there in the bottom middle section. You see those little insulated cups over the outside. The funny thing about these, most of these only work because you remove the hose and you've drained the system. Now you can protect yourself a little bit by insulating that valve and protecting it from some of those colder temperatures outside. But for the most part, they work because you remove the hose and let the water vacate the system. Now, the other thing that can cause a freeze and a rupture in the line is if it is not pitched correctly. And when we say pitch, we want the supply line to be slightly higher than the valve itself so we can let gravity do its work. Again, working towards that vacating the water out of the system, we want the water to drain out when it is shut off and the hose is removed. If your valve is pitched the wrong way and your supply line is actually lower than the faucet head, gravity is not going to be on your friend. It's going to keep water trapped in the bottom. There is no pressure forcing that water out. So that water sits there. It can be exposed to freezing conditions and it can lead to issues. This is a very small portion of what happens, but it does happen. And it's very important for people to understand you got to have it pitched correctly. You got to make sure that it drains properly. Now, one thing that we wanted to address is those two issues are leading to something where the valve needs to be replaced. Now, in many situations, the valve does not need to be replaced. It can actually be serviced. So we wanted to address some issues that can come up with a frost proof that can be fixed in the field with no special tools, and you can actually replace everything from the outside part of the building. So you're going to see issues with the valve is leaking from behind the handle. You're going to see water maybe coming out from that anti-siphon vacuum breaker. Or you may have issues with the valve just not shutting off when you got it in the closed position. You still have water trickling out. So one of the first things we want to talk about is if it's leaking from behind the handle. When we say it's leaking from behind the handle, during operation, you got water coming out. And most of the time you may see this if you got a closed in pistol grip on the end of your hose and you have a pressurized system. Water's always trying to fight its way out to that weakest point. And sometimes you're going to have an issue with it squirting out around either the bonnet packing nuts or the handle itself. In those situations, you have a packing issue. Many manufacturers are going to use a graphite packing where you are compressing it and you're conforming that graphite to fill the voids. We here at Prier use a stainless steel ring. We put it on our stem and you slide it back and it gives you a stopping plate on the back. We use a graphite packing, and then there's a brass nut that is going to go right over the top of that. What you're going to do is you're going to tighten that brass nut all the way down, and it's going to squeeze and conform that graphite to compress it. And then as you squeeze it a little bit more with a wrench, it fills those voids around the stem and prevents the water from seeping through. Now, some manufacturers will use O-rings. You'll have an O-ring on the stem itself, and you'll have an O-ring on the outer part of the packing. And these work great as well. But one of the problems that you do have with those is if an O-ring should fail with a scratch or a nick or a chip, or if there's something embedded in it, like a metal shaving or something as small as a hair can actually get embedded in an O-ring and can cause it to leak. So you want to make sure if you are experiencing a leak around the handle and you have an O-ring, you may want to inspect the O-ring, possibly clean it, put a little silicone on it and try and reapply it, see if that fixes it. If not, you may have to replace the O-ring altogether. With a graphite, over time, you may start to see that there's a little bit of a leak. You can take a wrench and simply just tighten it a little bit more. Again, it just squeezes that same packing and you're going to fill that void again, and it'll most of the time stop those leaks. You'll also see some manufacturers that use a combination of both. They'll have a graphite on the stem itself, and then on the exterior part of the nut, you're going to see an O-ring. Very similar applications to the graphite part with the compression, and the O-ring just kind of protects the outside. So if you're seeing leaks from behind the handle, you have a packing issue, most of the time these can be solved without even shutting the water off to the valve, as long as you're careful not to open the valve as you're working on the packing. This is the same application for commercial valves. So if you see a commercial valve and you're saying, well, I got no handle. Commercial valves are mainly a loose key, and it's the same principle. You're going to have a bonnet that's right over a packing, and you're going to see most of the time on a commercial, you're going to see O-rings versus graphite, but it's the same thing that you saw on the residential that we just accomplished. Either the O-ring needs to be replaced, cleaned, or the graphite packing needs to be compressed. Now, if it's leaking from the vacuum breaker. That's that little, we like to say, mushroom cap that sits on top of the valve. This is part of the backflow prevention device that we're going to talk about a little bit later. That's part of the code approval that prevents water from going back into your potable water system. One of the most popular ones is the one you're going to see on the left side of your screen. And in this application, what you have is the water is coming out of the back and it's draining properly. And in a pressurized system, it makes a float. You have a little piston style tooth that you see there that's got a washer embedded in it. During a flowing situation, that poppet will float up and it's going to seal around the top part of that bonnet that you see there on the top part. Now the cap itself, many people think that there's an issue with the cap. The cap is just a protective sleeve to prevent things from getting down inside the poppet and causing an issue. With a vacuum breaker, the parts under the cap are what is the main focus of a repair. You pop that cap off. Sometimes you'll need a little screwdriver or something like that, and you'll see everything underneath that needs to be unscrewed. Now this works simply like what you would see with a straw in a drink. So in a flowing conditions, you're going to see that poppet float up and seal. That is the same principle as you taking your thumb and putting it on top of a straw and pulling it out of your water. That water stays inside that straw. Now in a backflow condition, if there's a siphonage on the line and water's trying to go backwards, we don't want water to go backwards. And one of the preventions is this anti-siphon vacuum breaker. In that type of siphonage, it actually pulls that little poppet, that little tooth looking thing there on the side, it pulls it down and it releases that vacuum, and that's your thumb coming off the straw. All that water or drink leaves that system. Same principle here. If you're getting leaks from a anti-siphon, there is probably either something embedded in the washer needs to be replaced, or there may be a crack in the actual body of the vacuum breaker that's allowing water to seep around the sides. These are replaceable parts that you can find fairly cheap at wholesalers or other discount stores that all across the country. These are a part that are commonly replaced. But sometimes you can fix what you have by either applying some Teflon tape around the outside threads of that body, or by simply looking at that washer, making sure that it's clean. Prier uses a screen at the bottom of ours to prevent debris from getting in there, so it is protected a little bit more. But these, again, very easy to replace if there's ever anything leaking. Now, the other side of that may be a hose-threaded vacuum breaker. So if you're looking at the one there in the middle, it's the same premise. In a water flowing condition, your washer is covering the weep holes, and those weep holes allow it to create that vacuum. If you ever have a backflow prevention, all that water is going to do is when it tries to go back, it's actually going to push that washer up off those holes, and that is your thumb again coming off the straw. So with that on the hose threaded piece, part of the code approval says that you cannot remove that and be able to put your hose on, because we want you to have backflow prevention. So many times when you remove a hose threaded vacuum breaker, you're going to see a fine thread that is not a hose thread. You will not be able to adhere a regular hose to those because we cannot meet code compliance with that. So you're going to have some manufacturers that use a little set screw that will break off, and you will probably eventually have to replace that at some time. Or some manufacturers are going to use Loctite that you'll have to heat up and remove that particular vacuum breaker to swap it out. But again, they are completely serviceable. It is part of one of the funny things with ASSE. It has to be a permanent fixture, but it has to be serviceable. So we do make sure that you can repair these and replace these from the exterior part of the building. Now, if you see a vacuum breaker with a spring-loaded tip, so in our diagram off to the far right, this means that there's a backflow preventer with the anti-siphon vacuum breaker built in. So it is a dual check system most of the time when you see a little spring-loaded tip in there, but it's going to be replaceable just like everything else. Same thing you're going to see on a commercial product. The vacuum breakers may look a little bit different, but it's the same premise where the vacuum breaker is serviceable from the outside part of the building, you're going to have a washer that's going to seal those vent caps where you have a pressurized vacuum, and in a backflow condition, it releases over those holes. But there is no major difference between one and the other. Some just simply look a little different. Now, one of the last things you're going to see with a frost proof is, what if it's not shutting off? Most of the time, if a valve is not shutting off, we have something going on in the back end of the valve where the washer is closing the hole where the water supply is coming through. So if you can remember back in the earlier part of the presentation, you have a long pipe, runs into the heated part of the building, and your shutoff takes place inside there. Your stem that is coming through the valve has got a washer of some sort on the back end. That washer is closing off the water in the back part of the hydrant. There could be something embedded in the line. You will see, obviously, in many homes across the country, they have hard water or calcium buildup, which you'll see up in the top left corner. You know, a standard copper pipe or any supply line can have that calcium buildup over time. Sometimes that can get embedded into that little bitty hole in the back when you open the valve and then you go to close that washer. It's not getting a full shut off, and it's actually closing down on one of those pieces of calcium buildup that allows a little bit of a drip to continually come out. In that situation, what we want is to do a flush on the system. You're going to want to shut the water off to that valve. If you have to, you maybe shut it off to the entire building or home. And you're going to go out and you're going to remove the stem. You'll unscrew the handle, you'll unscrew the packing nut, and that stem assembly is threaded in the back. So you'll want to disengage it by unthreading. Once you unthread it fully, pull the stem completely out through the front. Now we want to do a pressurized wash. So we want to go back in and we want to turn on the water. Again, if it's the main part of the building, let's shut off all the other faucets and valves in the entire home. Let's have a designated stream of water pressure coming out this. You're going to turn your water on for about 15 to 20 seconds, and this forces a high concentrated stream of water to clean out that back end of that and clean out any of that calcium buildup that may have set there on the end. And many times this takes care of it. Now, sometimes there could be something wrong with the washer itself. If the washer has been in there for 15, 20 years, it could have a little bit of pitting in it. It could have some debris that scratched it. There's several different things that can do that. And sometimes a simple replacement of that bib washer will take care of your issue. Now, another thing that you're going to see is sometimes the threads themselves that are engaging the stem in the back can wear down. So let's say 30, 40 years of use, a valve will actually have a lot of water flowing over those threads inside of that head, where it's going to cause a little erosion. With some of that erosion, it wears down the points of the female threads and the male threads. And sometimes customers call and they say that the handle just keeps spinning, keeps spinning, keeps spinning. And sometimes it'll even have a little catch and then it'll just keep going. What's happening is your threads are not engaging any longer on the inside. Now, a handful of times, a new stem replacement will take care of that. But that does not fix the female part of the threads. The male threads are a little bit sharper when they come with a new stem. And most of the time, they are enough to engage into those female threads. But we have seen some situations where the female threads are worn down so much, even new threads won't engage. In that instance, a new valve needs to be installed. And we'll talk about a new valve and a new stem here in a minute when we get to the next part of the presentation. But that is something that sometimes does come up where a stem needs to be replaced. Now, a couple rare things that do pop up that we have seen over the years is an erosion case. Going back to if you have some buildup in the line like that calcium, or if you have a seat washer that has a nick in it or a crack in it that allows water to come through. When you have a closed valve, you have a pressurized system of water that's trying to escape in all different applications. It's looking for the weakest part. If you have a small line or you have something impeding the shutoff, sometimes that water can actually creates so much pressure that it wears down the metal in the back. In our application, we use brass, and sometimes you can see an erosion, or they call it a wire draw, on the back end part of the valve. Again, these are extremely rare. They do pop up. And many times you'll see customers that when they replace the seat washer, if they look at that seat washer, they'll see some kind of pitting or something in there. One thing they want to make sure that they look at is the internal part. Sometimes they need a little camera to get down in there to check it out. Or in many instances, customers will replace the hydrant just altogether just to be on the safe side. In the case of an erosion or a wire draw that you see there in the middle, you will need to replace the valve. A new seat washer will not be enough to close that. Once the lines have formed, water will continue to find its way in there. It will continue to wear those down to the point where those cracks will just get bigger and bigger, and the valve will never truly shut off. Now, an even rarer situation is what you see on the right. We have found situations where a home or building is improperly grounded on the electrical side. You'll see the discoloration of a bluish white color, and you'll see some charred marks on the end that have actually left a pretty big gouge in the seat. This was due to an electrical failure of grounding the proper valve. Sometimes this pops up because our valves are all metal, all brass, all copper. They're looking for a conduit, and if the house is not properly grounded, it can find its way into the valve, and the connection in the back, the water can actually pass through the water itself. Now, these are very rare situations with the wire draw and the electric parts, but we want to make sure you are aware of all things that could happen with a particular shutoff for a frost-proof wall hydrant. Now, let's say you need to replace a valve or replace that stem altogether. So we are going to look at how to see what you have and figure out what needs to go in next. So the first thing you want to do when determining what you have is you want to measure your stem. Again, you're going to want to shut off the water to that valve or to the home as an entirety, and you're going to want to remove that stem. And what we want you to do is measure from tip to tip. Once you know the overall length of that stem, the next thing you're going to do is find out who is the manufacturer. Now, most manufacturers should kind of have some marking on the head of the valve that's going to indicate who they are. We love to put our names directly on it. Some of our competitors are doing the same. Now, you will need to take that information and go to that manufacturer's website. You're going to want to pull what's called their specification sheet or spec sheet that is going to detail all the parts and wearable components for that product. Now, I do want to state you're going to have a lot more luck with a domestic product over an import. If you have an import, you don't know the name of the valve, you're going to have a tough time finding replacement parts, mainly because those typically have design changes that happen every 5 to 10 years. And once they're done, there is no replacing them. You will have a lot more success with a domestic product where you will be able to service and repair your existing valves. And tracking down what you have is the most important part to repair. Now, if you're replacing, you can use some of that same information. You're going to know that stem length, and you can report back to that manufacturer's spec sheet and find out what is the length of your valve. Now, one thing that is important to know is there is no standard for frost proofs when guarding the length behind the wall. When we say a 8-inch frost proof, that means that you are getting 8 inches of frost proof protection from the back of the flange to where the water is shutting off. That is your length. Now, that is not the only thing that is going to be a length in the wall. You also have the connection. Now, some manufacturers will be 3/4 of an inch. Some will be 1.5 inches. Some can be longer. That is just a manufacturer's choice of what that length is going to entail. So it's very important for you to kind of learn who the manufacturer is, find out what that length is so you can look at a replacement to make sure you're getting a proper length that can swap out what you currently have. Now, after you know the length, The next thing you're going to want to know is how's it connected to your water supply line. Now, many manufacturers are going to have several different options. These are some of the choices that we have with Prier products. One thing that we do want to point out that does cause a little confusion is the dual combination. So if you look up in the top left corner, you're going to see what we call the D style. And it says it's a 1/2 inch MPT by a 1/2 inch sweat. This is a dual connection. This is not either or. The customer can pick. It's either going to take a 1/2 inch copper supply line and put it inside and they can solder, or if they have a 1/2 inch female pipe thread, they can take that 1/2 inch male thread and screw it in. It's a dual connection. Same thing with the T style that you see there. When it says it's 3/4 male by 1/2 inch female, that's saying you can do either or with that combination. So you want to determine what do you have. Do not simply remove the screws on the outside part of the building and start yanking on that valve because you just don't know how it's connected. It could be a PEX. It could be a solder. It could be glue. It could be threaded in. There's so many different options. You will need to get into the home itself and get a visual of how it's connected. Sometimes that does entail cutting sheetrock, but it is most definitely going to be needed for you to replace a valve to make sure you are doing it properly when installing the new one and deconnecting the other one. So the last part of the presentation, we want to talk about some plumbing codes that are affiliated with these valves. Now, most of the time you're going to see some type of label on a manufacturer's product, and this means that they've gone through the testing cycles to meet these standards. Going back to what we had talked about earlier, in the 70s, the Safe Water Drinking Act had come about to enforce certain standards for manufacturers to make sure that the water is safe. We want to make sure that there's no water in a pool that goes back into your drinking water. There's no bucket full of chemicals that goes back into your drinking water. Now, that's a very rare, harsh condition, but at the same time, it is a prevention. And these standards through ASSE and the UPC, these are pretty much standards that are in place to show that you've had that testing, that your products are meeting those demands. Now, 4 of the main codes that you'll see pertaining to a hose threaded valve are going to be a 1011, 1052, 1019, and a 1057. So we're going to go through a couple of these, but to give you a quick little synopsis of what each one is, a 1011 is a hose piece connection that has a vacuum breaker only. The 1052 is going to take that same hose threaded vacuum breaker, but it's also going to throw in a backflow preventer, also a hose piece only. Now, a 1019 is going through the freeze-proof protection testing, so it shows that the valve has been tested for freezing, and it also has backflow prevention and vacuum breakers as well. And then the last part is a 1057. This is actually, they say it's for the sanitary, but it's the same as a 1019, but it applies to ground hydrants. So if you have a wall hydrant, it's more than likely going to meet your 1019. But if you have a post yard hydrant, it's going to be looking at a 1057, meaning it's frost-proof and it has backflow preventers. So the 1011 and the 1052, one thing that we want to say, these are not a valve code approval. These are a simple backflow preventer that's typically a hose threaded piece that goes on the end. So at Prier, we have a couple different models that we're showing you here, but you see there is no valve. A 1011 and a 1052 is simply focused on the hose threaded piece of the valve, not the valve itself. So these are meant to be serviceable, meaning that you should be able to unscrew them. Again, you can either have them pipe dope, or you're going to have Loctite, or you're going to have a set screw. So many different ways to get these set where they're quote unquote permanent, but serviceable. These are for the 1011 and the 1052. Again, the 1011 is just the vacuum breaker. So essentially in a flowing condition, all you're going to have is a washer that's going to seal over some atmospheric vents to make sure that you create that vacuum in a flowing condition. In a backflow condition, that washer is going to fall off of those vent holes, and it's going to make that vacuum close, where you're essentially, again, removing your thumb from that straw, letting no water go back into the potable water system. Now, the other part of that is our P003. This has also got a little bit of a backflow prevention piece in it with the vacuum breaker. You'll see a spring-loaded contraption in there, and what we call a biased open position. This is when a hose is disconnected. You can see the plastic piece falls off and it's sticking out, and that poppet is off of the yellow washer that you see there at the top. This allows the water to drain from the system. The biased close means that there is more than likely a hose attached, and it's up in there, and you'll see it sealed on that washer. Now, in a pressurized system, when the water is flowing, it has enough pressure to push that spring down, allow the water to come out. In a backflow condition, it will actually force that spring to close back up, and that poppet will actually close there, and it'll seal up against that washer to prevent the water from going back into the potable water system. So this is a 1011. A 1052 looks identical. All we do is we add an additional check valve on the end. So you have a vacuum breaker, and then you'll see out there the check valve number 2 is a backflow preventer. We use a neopearl, but this prevents the water from going past that point. If this should fail, your vacuum breaker is the secondary backup. So a 1011, 1 check, a 1052, 2 checks. Now for the 1019. So a 1019 is going to give you those vacuum breakers, it's going to give you that backflow prevention, but it's also being tested to a standard of a frost proof, meaning these have been installed in a certain application at a third-party testing facility. Typically what that means is they're putting it into a cooler with some dry ice. The head is mounted, and then the pipe itself extends into, quote unquote, the heated part of the building, and they will let it freeze for several days, run the test, and if it will still operate and flow, then it passes the 1019. And of course, they're going to do some of the same checks that we're doing on the 1011, 1052, make sure that the backflow preventers and the vacuum breakers are still working. But when you see 1019, it means essentially it has been tested to a frost-proof standard. And there's a couple different codes that are going to fall under that. Essentially, some of them are just setting, they relieve the pressure when a backflow is happening, allowing that water to leave the system and not going back into the potable water, or it's holding the pressure. So water just stays where it is, nothing's going back, but nothing's relieved. Some applications allow the hose to be removed, and they say that's how it forces the frost proof. There are some applications where it's saying that you don't even need to remove the hose. It's going to drain automatically, and it's still going to meet all those standards. So when you see 1019, just know that that valve has been tested to a frost-proof standard, and it does have backflow prevention. Now the 1057, I know it's got a little bit more wording here. It is the exact same thing as a 1019. It just is going to pertain to yard hydrants, ground hydrants. When you're burying that freeze protection into the ground, your supply line is down below the frost line, and that changes depending on where you are in the country. But this is going to allow that frost line to drain the water from the system. It's going to have the backflow preventions. Everything we have with the 1019 is in a 1057. It's just the different application. The 1019 pretty much says wall hydrant. A 1057 pretty much is going to pertain to a ground hydrant. Now, a couple other things you'll see with the letter of the law is these NSF, ANSI 61, NSF, ANSI 372. Now, the 61 is a little tighter standard. This is pretty much saying that the water is safe for consumption. That means that it is drinkable. The product is making sure that nothing's leaching into the system. It's a high standard that many indoor faucets are going to need to meet to make sure that the water is safe for consumption for the end user. Now, the other part of it is that 372. This is saying it's lead free. Now, the 372 can pretty much fall under the 61 because the 61 is a little bit of a broader spectrum of what they're looking for. It also encompasses a 372 because a 61 wants the water to be lead free as well. But a 372 is saying that the wetted surface of the product is not allowing a maximum allowable weighted average lead content below or above a 0.25%. So these valves are saying that the leaded material is below this weighted average. These are standards that meet that Safe Water Drinking Act. But with that said, there is exemptions. Under that exact same code, you'll notice that many of the exemptions fall to used exclusively for non-potable services. Non-potable services are for non-drinking water applications, non-cooking applications, and it even specifically calls out irrigation and outdoor watering. So these exemptions pretty much state that Prier or any other hose-threaded manufacturer does not need to meet these laws. Now, we do offer products, as well as some of our competitors are offering products that meet these, but it is not needed per the code. That pretty much sums up a lot of what we have to offer today. You know, one thing we wanted to kind of tout is, you know, Prier is a wall hydrant manufacturer, again, based in Kansas City, Missouri. You know, this is what we live and we breathe. So we do this to provide a value to you, your team, your customers. You know, we want to make sure that we are assisting in all things wall hydrants. And with that said, if you should ever have questions or you need information pertaining to a valve, we would task you to reach out to Prier. We're at prier.com. You can email us at orders@prier.com. Call us toll free. Reach out at any time. We are here to assist you. Customer service is ready. We're here 8 to 5 every day Central. Please reach out. We're happy to help you in any of your wall hydrant needs. Thank you for your time today. Have a great day.